Okay, here's another question on constant acceleration. So the first thing we do is we write down our three equations of kinematics. Final velocity equals initial velocity plus acceleration times time. Final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. Displacement equals initial velocity times time plus 1/2 acceleration times squared. Now we're going to write down our givens as we read the question. Cheetahs, the fastest of the great cats, can reach 57 miles an hour. So that's a velocity. I don't know if it's final or initial yet. Equals 57 miles per hour in 3.1 seconds. So the time is 3.1 seconds. Starting from rest. So this is obviously the final velocity, and the initial velocity where he starts is 0 miles per hour. Assuming that they have constant acceleration is 27 feet per second squared. Throughout that time, find the distance. So we're trying to find displacement or distance in feet they travel during that time. Okay, so this question is a mess because typically the units, that's where they're tricking you in this question. The units for displacement are meters. The units for any velocity is meter per second, whether it's final or initial. The units for acceleration is meters per second squared. And the units for time is in seconds. But these guys put miles per hour, they have feet per second, they want the answer in feet. So what we have to do is make sure that the units are all consistent. It doesn't really matter. It's not more accurate if it's in meters or feet or seconds or hours. They just need to be consistent. So that's in miles per hour. Well, we want it in feet, so you got to change the miles to feet. In hour, we're dealing with seconds, so we have to change the hours to seconds. So I would recommend you just Google it. It's super fast and easy. But if a problem like this ends up on the final exam, you have to know how to convert the units. So I'm going to show you the long way, just for teaching purposes. You always write down your given. So we have 57 miles per hour. Okay, now this is called unit cancellation because the units tell you what to do. You can do the miles into feet or you can do the hours into seconds. It doesn't matter, either one. So we're going to do hours into seconds first. So since we're going to treat this as a number. So since this is on the bottom of, in the denominator, at the bottom of the fraction, we're going to put it on the top of the fraction and cancel it out like we would if it was just, 3 divided by 3 times by 3, they cancel. And we're going to go from hours into, we'll go into minutes, because everybody knows that there are in 1 hour, there are 60 minutes. So now, based on where the units were positioned, we know that we divide 57 by 60. And that gets it into minutes, not seconds. We want it in seconds, remember, because we have seconds down here. So we're going to do it again. But this time we're working with minutes. So minutes is on the bottom, so you put minutes on the top. And we're going to move it into seconds. And we know in 1 minute there are 60 seconds. So we cancel those units. So now our units for time is not hours, it's not minutes, it's seconds. And we know that in order to put 57 miles per hour into miles per second, we divide 57 by 60, and then we divide it again by 60. Now, how do we get rid of the miles? Same thing. So miles is on the top, so we put it in the bottom. Cancels out. And we want to go miles into feet. You don't have to memorize these. Unit cancellation, or unit equivalent statements, that's what these are called. You can just Google them. You shouldn't have to memorize any of them. Okay, so I know if I Google this, there are 5,280 feet in 1 mile. So in order to convert miles into feet, I multiply by 5,280. So now we get our calculator and we do some math. What we're going to do is we're going to do 57 divided by 60, and we hit equals. And then we divide that, so divided by 60 again. And then we multiply that, so multiply 5,280 equals. And I get 83.6. So 83.6, and it is in feet per second. Let me do a line there, which is consistent with my acceleration, which the second is consistent with my time, so that's what I want to do. And this is 0 miles per hour. We can just change that to feet per second because 0 anything equals 0 anything. So 0 miles per hour is the same as 0 feet per second or 0 meters per second or whatever. So now we need to find the displacement. And we have 4 variables, and we're looking for a fifth. We match these up to these equations over here, the equations of kinematics. We can use either this equation or this equation. This one doesn't have displacement, which is what we're trying to find, so we can't use that. But we can use this, and we can use this, because we have VF, we have VI, we have A. Down here we have VI, we have T, we have A, and we also have T. So which one's easier to solve for displacement? Obviously this one, because it's already solved for displacement. So let's just plug the numbers in here. Recopy it down. It's a very good habit to do that. I highly recommend that you do that. So our displacement is VI is 0. Our T is 3.1. 0 times anything is 0. Plus 1/2. A, what's my A? 27. Times time squared, what's my time? 3.1. And it's just the time squared, not the whole thing squared, just the time is squared. So now we're going to plug into my calculator and see what we get here. We get 3.1 squared times 27 equals times 0.5 equals 129.7. So 129.7 meters. I'm going to round that. I typically use 3 significant figures. In the course, they're all over the place. So we just kind of, in general, use 3. So that'll be 130 meters, because that will round up for my displacement. Now, if I chose this equation and I solve for the D using these numbers, I would get the exact same answer. This is a multiple choice quiz or assessment, so we want to make sure that we understand just because I get 130, the multiple choice might say 131 or it might say 129. It just depends on how they rounded and how many significant figures they took from here. So just be aware of that.